So I think we're all set to go. Let's get the meeting started with Andy and the sky this month.
Oh, I hope everybody can hear me. My name is Andy Beaton. I'm speaking to you from my astronomy cave in downtown Toronto. I'm here to talk about what's up in the sky this month. The usual agenda whenever I'm doing this, the big picture, key dates, moon, planets, the deep sky, a double star, even though Blake isn't here, I'm still keeping him in mind, a variable star, and some spaceflight highlights. So starting with the big picture, tonight around 10 p.m., looking to the south, this is what we're seeing. We're looking at our usual late summer, early fall constellations. We have a great parade of planets. We've got all the big planets in view. We've got a couple of minor planets. Pegasus is right up there. Looking over the top of that, they're all going to have Andromeda and Cassiopeia, so there's lots of good deep sky stuff to look at. When we get later in the month, or right before the next meeting, wake up early in the morning, and we're going to have our winter constellations. I know this is bad news for some of us who prefer the summer, but at least we get some good stuff in the sky. We have Orion, we have Gemini, we have all the winter spectacle in the sky that we like. I've thrown an extra one for this month, Halloween. I'm assuming that Halloween is going ahead and there will be kids wandering in your neighborhood. If there are, this is what you're going to be seeing on Halloween night around 8 p.m. Bright planets, summer constellations are still going to be around to a limited extent, so if you have a telescope, you can always take it out. We're at the time of the year where nights are starting to get longer. Tonight, astronomical twilight ends at 8:10 and starts again at 5:26 in the morning. This is all daylight savings time. By the next meeting, November 3rd, twilight will be ending at 7:28 or 19:28 if you're counting that way, and starting again just before 6 o'clock in the morning. So we got more time out there. If you're one of those people who's doing some imaging, you've got lots of time for nice long light collection. Important dates coming up. Strictly speaking, the new moon passed earlier today, but I'm throwing it in today anyway as part of this month. As far as we're concerned, if you go out with your telescope tonight and the clouds miraculously disappear, tonight's a new moon night. You'll get your darkest possible sky. The moon is at apogee on the 24th and perigee on October 8th. I've annotated it there as far and close because I never remember which is which. But if you take out your telescope and a camera and take a picture of the moon at both times and put them side by side, you can see just how elliptical the orbit of the moon around the Earth is, and see how much farther it gets away at its greater distance. October 20th, we've got the full moon. Mercury is occulted by the moon on November 3rd. It's a lousy time of day to see it, but it's worth giving it a chance. Halloween, I'm sure there are spooky things in the sky that we'll be able to see. And the Orion meteor shower is going to be peaking on October 21st. Here are the phases of the moon. First quarter on October 13th, October 20th, the full moon, last quarter on the 28th, and the new moon early today. On October 13th at 6:16 in the morning, the Lunar X appears. And for any first-time listeners who haven't been here for this talk before, the Lunar X is an intersection of two craters. And at a certain time of the month when the angle of the sun is just right, The ridges at the top of the craters are light. The valleys in the center of the craters are dark, making it look like an X on the moon. It doesn't actually do anything useful, but it's kind of neat to see. I'll also point out that October 13th is my birthday, so don't hesitate to send presents and good wishes. Planets coming up. Start with the rocky planets. Mercury is visible in the morning around the end of the month. It's not an outstanding apparition this time, but it should be visible if you're willing to get up early. After sunset, Venus is visible low in the west. Its excellent apparition from the summer is disappearing. It's going to be gone pretty soon. Mars is behind the sun. It's a hopeless case for this month. You're not going to see it. Saturn and Jupiter are the big ones. I'm sure that everybody has seen Jupiter blazing away in the southern sky in the past few nights. Saturn is actually pretty prominent. If it wasn't for Jupiter, you'd say, hey, wow, look at Saturn. Jupiter's about a hand's width behind, and you know it's unbelievably spectacular. There's no way you're going to miss it. Unfortunately, neither of them are particularly high in the sky, even at their best. So the best imaging you're going to do, you're not going to see the finest of fine details from here. On the other hand, if you're not in Toronto, if you're somewhere further south, then the planets will be further overhead, and there will be no limit to what you can see. They're going to be excellent targets. Saturn's rings are good and wide open, so you'll have a good view of those. And it's always worth showing people Saturn just as take them out for their first view through a telescope. Now, if it is clear on Halloween, in the before times, I always used to like to take a telescope out onto the front lawn and set it up and let the kids have a look at the moon or interesting planets or anything that's out there. We're lucky this year. The moon is lousy, but we have two fantastic planets to look at. I know through experience that kids absolutely love Saturn. It looks like what they expect a planet to look like. So if you want to take a telescope out there and of course, take appropriate health measures, have alcohol wipes to clean the eyepieces between kids, keep everyone safely distanced, don't cough on them, don't lick their candy. It should be a reasonable thing to take a telescope out and share some astronomy with the kids. Uranus and Neptune, they follow along behind the big giants. Uranus is in Aries, and it is approaching opposition, so it's going to be its brightest and biggest and the best view you're going to get. It's not terribly high in the sky, but you'll at least see it at its biggest. When you are showing it off to people, this is the time to show it. We'll actually be able to see a disk with any reasonably sized telescope. Neptune's actually between Uranus and Jupiter. It's obviously not as bright. Its position in the sky is not as good. But if you're gathering planets, if you want to show off planets to someone who's never seen them before, it's a good chance. The little guys, the dwarf planets, we can argue later, and we'll meet in a bar and argue whether Pluto's a planet or not. Pluto is in Sagittarius right now. It's getting away from the Milky Way. It should be visible after twilight in the early night in something like, say, a 10-inch or larger telescope. It's probably around 14th magnitude or so. Ceres is much brighter, and it's passing through the Hyades over the course of the next month. And on November 3rd, we'll be 7 arc minutes away from Aldebaran. So that will be an interesting target to look for. Hopefully you'll see something, be able to have some fun watching it move from night to night through the star cluster. I always like to do a little bit of deep sky stuff. This month I've picked something a bit more challenging. This is for the more experienced observers. I picked Stephan's Quintet. It's a cluster of 5 galaxies in Pegasus. I mean, strictly speaking, it's a cluster of 4 galaxies, and there's one more galaxy between us and them. Going from about 14th to just sort of 17th magnitude, so a biggish telescope in order. I have the 8-inch telescope back there. I have never seen Stephan's Quintet with it, though I've tried hard under good skies. So I would say you're looking at a 10-inch, maybe a 12-inch telescope and better to be able to see it. It is the closest multi-galaxy cluster. I mean, not just one or two and some dwarfs, but actual real galaxies all together. I've got a picture of it here. You can kind of tell which ones are the cluster members and which one's the interloper. The bright white one to the upper left is the closer one, and you can see the others. They're kind of distorting each other through gravitational effects. The important thing I want to point out here is of the 3 yellow ones there. If you take a close look at the middle one, you'll see it's actually 2 galaxies. It is, here we go, NGC 7318 A and B. So if you're looking for a challenge and you've got your big telescope out there and you can see the galaxies, see if you can separate the cores of those 2 tightly connected galaxies. If you're an imager and you're looking for a challenging project, try and get the H2 regions in NGC 7320. I'll just go back to the picture here. I don't know how well it shows up over the internet here, but looking at the galaxy on the top left, there's a number of bright red hydrogen blobs in there. So they would be an interesting target for someone with a taste for imaging. I mean, this is a space telescope image, so you're not going to get that, but hopefully you can do something good with it. Comets and meteors coming up. We do have meteors. We have the Orionids. That's one of the better meteor showers. I think we're looking at 20 notable meteors an hour, and it's a day either side of October 21st. Unfortunately, it's going to be pretty moony, so we'll just get the brightest ones, but if you're out and observing anyway, hopefully you'll find something good there. For a week before and after November 5th, we have the South Taurids. I wrote Taurus there because I'm a lousy typist. Not a particularly dense shower, but you'll get a few per hour. We also have a few meteor dribbles, not quite a shower. We're currently in the middle of the Epsilon Geminids. They'll be going on till well past the next meeting. The Leonis Minorids, going from October 13th till November 3rd. And the Draconids, which are a variable shower. Usually you'll get 1 or 2 a night, nothing very interesting. But every now and then, you get a spectacular show. And who knows what's going to happen. Anyway, it's the night of October 8th and October 9th. So if you're out and observing, I wouldn't make a special trip to see it, but if you're there and you see a sudden shower of meteors, you'll know what's going on. Got a few comets, nothing too spectacular this time round. 9.5 magnitude in Hydra for 8P Tuttle is as bright as we get. We've got Churyumov-Gerasimenko in Taurus, it's 10th magnitude. 2020 T Palomar in Scorpius. You're going to have to be right after twilight to be able to catch that one. Later in the month, Churyumov-Gerasimenko will be dimmer, but in Auriga, so you can follow that one around. And C2019 L3 Atlas is 10.6 in Lynx, and that's one that people are talking about being spectacular. It's not there yet. We'll see what happens. We have to have a double star because Blake will be sad and I'll feel like I've let him down if we don't. I've picked Gamma Andromedae this time round. It's a bright, multicolored pair, second magnitude gold star and fifth magnitude blue star. Really nice binocular object. It's down at one of Andromeda's feet, if you know how the constellation picture goes. If you have a really good telescope and a night of excellent viewing, you can actually split the 5 magnitude blue star and realize it is in fact a double. Now, if you're a professional observer, with a spectroscope and research quality telescope, you can actually split that double and realize that the secondary is a spectroscopic double. So you're actually looking at 4 stars at once. So it's a pretty interesting double star from the point of physics, getting 4 stars in a stable configuration, and it's a nice one to look at. It's very pretty. So that one's my pick for this month. Now, people who have talked to me about astronomy before know that variable stars are my thing. That's my obsession. And I always like to have a variable star here, so I've picked HD 189733. It's a 7th magnitude star in Vulpecula, and what's cool about it is why it varies. It's orbited by a hot Jupiter. Every 2.2 days, the plane of the ecliptic, or the plane of the orbit, is lined up just perfectly with us, so it passes between us and its star. For about 2 hours, we'll get a 3% drop in brightness of the star. I don't think anybody could spot that visually, but anybody with a photometer or even a good camera can detect that much of a shift in brightness. And I've never seen an exoplanet, but this is probably the closest I get if I can get out there and actually get this thing to work. And it's also an opportunity to contribute to science. The Exoplanet Transit Database solicits observations from people like you and I, amateur observers who have the time and the energy to go out and do the observing that professional astronomers don't. And there's a finder chart, bit of one courtesy of Sky Safari. And what we have here is our constellations of Vulpecula and Sagittarius. And that little white arrow, I hope that you can see it better if I upload the presentation when I'm done so that people can download it. And it's kind of right between there. I can't really point because you can't see where my finger is, but it's right there, that white thing in the middle. You can also dig out your own astronomy software and track it down, HD 189733. Frank Dempsey actually drew my attention to this, so I'll say thank you very much, Frank. And while I'm on this theme, I will say that my sources of information are not all-encompassing. If you know of something interesting coming up in the next month, if you see that I'm going to be doing the presentation, feel free to contact me and tell me about whatever cool things you've got on your mind. I know Dennis Gray has sent me useful information before, and I've been grateful, and Frank is the man this month. He pointed out that Nova Cassiopeia 2021, or V1405 Cassiopeia, as the variable star people call it, is still at remarkable brightness, between 7th and 8th magnitude, 7 months after discovery. It's an easy binocular target. It's pretty close to CAF, or Beta Cassiopeia, and M52. And if you're interested, once again, in doing some real science, you can measure the brightness and report the results to the American Association of Variable Star Observers. And there's the website there. I urge everybody to do this because this is timely and useful stuff. And if there are changes in the brightness that occur faster than, say, every 2 days, those changes are not going to be caught by the automated sky surveys. That's where the professional astronomers count on people like us to actually go out there and observe more frequently than the automated cameras get and catch all the little fiddly bits in the light curve that are so interesting. And I've downloaded a chart here with the variable, with the nova and the brightnesses of stars all around it. The bright star in the bottom left is Beta Cassiopeia, and there's a couple of fourth and fifth magnitude stars around there that make it an easy star hop to get from one to the next. So if you're interested in doing some real science and seeing a real live nova as it undergoes its eruption, please get out there and do that thing. Coming up in spaceflight, I'm giving up counting all the SpaceX launches. There are just too many of them, and unless there's anything spectacular going on, like multiple launches at once or anything unusual, I think we're just going to call them mundane and let them go. But Perseverance and Ingenuity are still on Mars. Look forward to interesting results once we get past, once the Mars gets past the sun and the flow of data comes a bit more regularly. We'll see some more results with the rock driller and the helicopter and all the fun stuff that we expect from rovers. The International Space Station is a film set. A couple days ago, Russian actress Yulia Parasil and her director showed up with a camera on the space station to shoot live zero gravity shots for an upcoming feature film. I don't remember what the film is called, but I'm sure once it gets released, it's going to be big news in the astronomy community because everybody is going to want to see what it's like on the space station when we get to an actual fictional story going on there. October 16th, the Lucy probe is launching to explore Trojan asteroids. And low in the south, between October 5th and 8th, we get a limited number of ISS passes. It's not a very good month for seeing the ISS. If you wanted to set up your telescope and see if you can see a Russian actress through the cupola window, it's a bad time for it. But heavensabove.com is the place to go for times and locations of flybys of the ISS. And of course, if you're not in Toronto, if you're somewhere else in the world, my predictions will be meaningless for you here. You can look it up yourself and get your own schedule of ISS passes. And because we're all long-term astronomers, we've done this for years, we know that whenever any of these interesting things are predicted, what we're actually going to get is clouds. I've got some recommendations for projects on zooniverse.org. These are all projects where you and your computer go to the website and you're asked to classify, examine, note interesting features in radio galaxies, asteroids that may be active or having unexpected comet tails, weird dark energy effects on distant galaxies, or bursts of gamma ray energy that are coming from unexpected times. These are all projects that any of us can work on when we're stuck inside because the sun is out or the moon is out or the inevitable clouds are covering up the thing that we really wanted to see. But those are out there. So that's what I've got for this month. let's all have clear skies and a good month of observing.
Hold on.
And if there are any questions, I will be happy to hear them.
Hello, Andy. Thank you so much for your presentation. Great job as always. Let's go to Emma. Do we have any questions for Andy?
We do. We have two questions. From Louise, does the sun appear to move faster or slower than the moon as we see it from the Earth?
Oh, good question. The sun, if we're looking at the sun at the background of stars behind it, then the sun appears to be much slower. It will be an entire year before it gets, that one circle around the Earth from our point of view. The moon only takes a month to get from one point in the sky to circle around and back to the same point. So it's going roughly 12 times the speed. So when you see a solar eclipse, you're seeing the moon catch up to the sun and pass it rather than the other way around.
Thank you. Our second question is, when will Pluto get away from the Milky Way?
Well, Pluto is moving extremely slow. It's kind of at the edge of the Milky Way, the densest part of the Milky Way now. But the problem is the Milky Way is not a clearly defined thing. It doesn't have a sharp edge where we can say, okay, here it's in the Milky Way and here it isn't. I would say give it another 3 or 4 years and it will be definitely away from the Milky Way, but it's away from the densest part now. If you'd asked me 5 years ago, I would say don't bother trying to look for it visually because there are just too many stars around. Now, I think if you have a decently sized telescope and a good dark sky, you shouldn't have too much trouble finding it. All usual disclaimers apply.
Thank you. Our last question is, what is an exoplanet?
Exoplanets are planets that are orbiting stars other than the sun. 15 years ago, 20 years ago, I think we knew of a couple. Now, I think we know of something like 3,000 or 4,000 of them, and they're discovering more just about every day. Unfortunately for us, spotting exoplanets is really difficult. They are extremely dim and almost always washed out by the brightness of the star they orbit. The best way we can spot them is with an extremely precise telescope and measuring the wobble of the star as the gravity of the planet pulls it back and forth, or when the planet passes in front of the star. And that was what I picked for this variable star.
Cool. That's all the questions. Thank you.
Okay, thank you.
Great. Thanks again, Andy.